When you guys get to YouTube, can you go ahead and check and see if you can see my live? Yeah? Could you check on your phone and see if you can hear it? There might be a slight lag too, but I want to make sure that audio gets recorded. I'm still trying to figure all this stuff out. Sounds good. All right. I'm going to grab some more coffee. There's coffee if you guys want. A little bit of creamer over there too. And then we'll get started. You guys got that light off? Yes or no? Light off. Light off. All right. Thank you. All right. Everybody on live? Hey, Don Lee. I know. I was going to ask you where they keep going.
Someone keep them? We have to erase it, but 0 markers.
Go ask Shawnee. There's more. She's got all the markers. Shawnee is that lady that works in the office next to the boss. Yeah. Oh, Don. All right. You guys can see my screen, so let's get started. What I'm going to do is I'm going to start a new Rhino file. So File, New. Should I use the large object template or small object template? What's that? Large? Why large? The comparison is to a pickup truck. So is what we're making smaller or larger than a pickup truck? Smaller. So we can go either route really because we're kind of in the middle, but let's go small. And I'm going to do inches, feet, and inches. I like to measure things in inches, but I can also display things as feet and inches. So I'm going to use small objects, inches, feet, and inches. All right. First thing I want to do is I want to make a rectangle. I like to use a 3-point rectangle. So when I use a 3-point rectangle, the first thing you do is to define the start of edge. So I want to start my rectangle at the origin, so I'm going to hit 0 and hit enter. Okay. Now if you see it like this, give me 1 second. Clip this on. So 3-point rectangles. I like making 3-point rectangles. You could do another rectangle like this one right here. That's 2-point rectangles. You define one corner, then the other corner. I prefer 3-point rectangle. So you right click here, and then you click 3-point rectangle. Oh, I'm going to turn this on too. All right, so I'm going to start it at 0. I'm going to hit enter. When you hover your cursor around during a command and you can see that you can freely move at whatever angle, that means ortho is off. So I'm going to turn ortho on, and ortho makes me move in straight up and down, straight left and right movements. Mine also allows me to go at 45-degree angles. You guys can do that too, but you need to change your settings. And the next thing I want to do is I'm going to use this rectangle to define the basic outline of my cache wrap. So let's do something like 2 feet, right? I'm in top view right now. I'm in the plan view, so let's do 2 feet. I can type in 2 apostrophe, hit enter. I need to zoom out, and once you oh, sure. Are you seeing the YouTube? Okay, sure. Do you have the live on as well? Are you on YouTube? That's it. Refresh. Okay. Yeah. Now you can see. Better, right? Okay. I can display it up here for you guys, but I'd rather you watch it right in front of you. All right, back to the 3-point rectangle. So, yeah, so when you do record lives, they get recorded. So you're going to watch this later. Let's hold all our questions to the end so I can finish the exercise. All right, I'm going to start over. I had a lot of interruptions, so I'm going to do a rectangle, 3-point rectangle. Ortho is on. I'm going to type in 0 to start my rectangle at the origin. I'm going to type in 24 inches or 2 feet and hit enter. And now I need to dictate which direction I want my rectangle to go. So I'm going to go this way and click. And then I'm going to go this way, let's say 6 feet. I'm going to make mine 6 feet. So I can type in 6 apostrophe and hit enter. And then I can click over there. So that is the rectangle. So now I want to figure out where are my FrameCAD components. So what I'm going to do is I'm going to take my rectangle. When you draw that rectangle, all 4 of these lines are joined as one closed curve. What I'm going to do is I'm going to type in explode. When you type in explode and hit enter and select all 4 of those lines, they become separate lines. So instead of one closed curve, now it's 1, 2, 3, 4 open curves. And the reason for that is I'm going to do offset, and I'm going to offset the width of a stud. What is the width of a FrameCAD stud? Edith. Yes. No. Josue. No. Colton. June. What is the width of a stud? Albert. 3 5/8. Thank you, Albert. You guys should have this written down. 3 5/8. Okay. It's right there on the board too. And I gave a little sketch to you, and it had 3 5/8. All right. So I'm going to offset a distance of 3 5/8. So when you initiate any command, you're looking at the command line, right? I said offset. It says, okay, what curve do you want to offset? I say this one. If you look at the command line, it also says distance. That's where you type in 3 5/8. You say D for distance, and then you type in 3-5/8, quotation mark, enter. That's 3 5/8 or 3.625. So now I'm going to click on this side to offset it. I'm going to repeat that command, offset. I'm going to select this curve to offset. I'm going to choose the direction. So I'm going to choose this way. I'm going to type in offset one more time. I'm going to select this curve to offset. I'm going to offset it inwards right here. And that's good enough for now. So now what I want to do is I want to figure out All right, how tall is my desk? Okay, so let's say I'm going to make it very simple. I'm going to do a 3-foot tall desk. So you guys should already have figured out the measurements, right? The overall height that you want your cash wrap to be, right? And I told each and every one of you, there's also the wheel height that you want to account for. So if you know the wheel height for the caster wheels, and you know your overall height, and you know that we're going to have 1/2-inch plywood sandwich on the top, or not sandwich, but on the top of the box, then when you subtract all of that, you get the height of the actual frame CAD stud. Okay, so if I say I want a 36-inch tall final height, I want this to be at 36 inches. I need to know the height of the caster wheels. I need to know the thickness of the 1/2-inch plywood that I'm using, and that dictates how big the frame CAD part will be. So let's say I have, Albert, did you say you got like 3.5 or 4-inch tall for caster wheels? 4 inches. Let's call it 4 inches. We're not going to use these caster wheels that are over here, these red ones. We'll use I'll grab some different ones for us to use. We're going to need to measure that height. So let's pretend it's 4 inches. Okay, I'm just going to I'm going to show you guys some math. Okay, don't worry about replicating this part. But let's say final height equals 36 inches. I know the caster wheels, height of caster wheels, 4 inches. And thickness of plywood, 1/2 inch. Now when we go get that 1/2-inch plywood, it's likely not going to be exactly 0.5 inches. So if we wanted to be super nitpicky and get the final height to be exactly 36 inches, we would need a caliper to tell us exactly how thick the plywood is. 1/2 inch is a nominal number. It's probably 0.512 across the board, but we're just going to call it a 1/2 inch, right? So with that, if I want the final height to be 36 inches, I subtract the caster wheel height and I subtract the 1/2 inch. So let's get our calculator out. Did you guys know that Rhino has a calculator? Let's right click over here. I think you can get it here. Let's type in calculator. Here it is. Little Rhino calculator. Okay. So I'm going to type in 36 minus 4 minus 0.5, 31.5. So that tells me that the frame CAD portion of this project, I need to set the height of the frame CAD walls to be 31.5. So now that I know that information, I'm going to come over here and I'm going to go to perspective. And what I'm going to do is I'm going to start off by creating some 3D boxes. When I do my boxes, I like to use box 3 points height. So I'm going to click on this one. Oops. And I'm going to start of edge will be here. Okay. End of edge will be here. Width will be here. And then the height is 31.5. As you type that in, if the box that you're creating goes upside down, just type in negative 31.5 before you hit enter. And when it looks correct, just hit enter. And now you have a 3D box. Okay, that's going to represent my frame CAD wall. I can go into more detail later on, but I'm going to start with big massive chunks of things like I'm carving out of stone. And then by the end of this exercise, I'll actually start to model my studs. So let's do that box again. I'm going to right click here on box. I'm going to right click on this box. I'm going to find 3 point, start of edge. end of edge, width, height. For the height, I can type in 31.5, or I can use O snaps. Make sure your O snaps are on. Have all of these O snaps on except for those ones. Just have all of these 7 on. And then I can snap to the end point of the other one that I already created, and it will create another wall that thick. Now all I need to do is grab one more, create one more wall. So I'm going to do a box, right click, I'm going to right click box and do a 3-point box, start of edge, end of edge, width, and then the height. All right, so these 3 walls represent my frame CAD walls. They're 3 5/8 thick, and then I'm going to start to model each and every individual stud. Once I get to designing where the studs go, I can actually use that to my advantage and think about things like, oh, what if I had a shelf that went from one side to the other? Well, maybe I want a horizontal stud going this way, so that way I can put a sheet of plywood right there and have a shelf. So now that I have the basics of the wall, I'm going to go ahead and start to model each stud, which doesn't take that long, really. It's not that scary. So I'm going to first start to organize all this. I like to use all of my layers here to keep everything organized. I highly recommend you do it. So I'm going to select each one. I'm going to click one, hold shift, click the other one, click the other one. I'm going to put them on layer 1. Right click it and change object layer. Now they're all red. I'm going to lock that layer. I'm going to activate layer number 2. I'm going to make it the current layer by clicking in this column on this row. And now in this purple layer, I'm going to start to 3D model my studs. Same thing. Box, right click this one and do a 3-point box. Start of edge, end of edge, width, and what's the other dimension for the frame CAD? We know it's 3 5/8. What's the other number? 1 5/8. Thank you, Colton. 1 5/8. I can see that it's going in the wrong direction, so I'm going to backspace and do -1 5/8. Okay. If I turn off layer 1, that's one stud. Okay. Simple, just a box. And turn this layer back on. I'm using it just for reference. It's locked, so when I go to click it, I can't accidentally move it. I can't accidentally delete it. I can only affect things here that are on layers that are not locked. Okay. So everything I've just selected right now is not on a layer that is locked. I'm going to delete this text. I don't need that. So now what I can do is I'm going to model the rest of this. I'm going to select that one stud that I made. I can go through the work again and do a box, 3-point box, start of edge, end of edge, width, height, or I can select that box, type copy, point to copy from. This is super important. Point to copy from with O snap on and these snaps activated. I'm going to come over here and find the end. When your cursor snaps automatically to a very specific object snap, and it gives you a little tooltip like it's doing right now that says end, comma, int. That means it's snapped to a very specific point in the geometry, and that's what I want. I want this end point, this corner right here. So I'm going to click it. That's my point to copy from. And now in the command line it says point to copy to. I'm going to move my cursor over here, and I'm going to find the other end or intersection or perpendicular of the red wall. And once I find this corner, I click. And the command line it says press enter when done. I'm done, so I'm going to hit enter. And that's how you copy one stud from one corner to another very specific corner. So now let's worry about doing the middle stud. I might need a middle stud. I might not. It's 2 feet deep here, so I actually don't need one. You should put a stud every 2 feet on center. Okay? If you have a gap between your studs that's over 2 feet, that's a little too much. So 2 feet on center is standard with 20 gauge light gauge steel. I'm going to do the bottom plate next, the top plate next, and I'll put a horizontal piece in. So I can actually turn off my red layer. I don't really need to look at it right now. I'm going to do right click on the box, right click on this box, 3-point box, start of edge, end of edge, width. I'm going to move my cursor up, type in 1 5/8, enter. I'm going to select that bottom plate. I'm going to type in copy. This time I want to copy from one of these top corners. So I'm going to make sure I snap to that end point and click it. I'm going to zoom out, I'm going to pan, and I'm going to snap to the top of the vertical studs. When it says that I've snapped to it, I can click it there. And if it looks right, hit enter. Always hit escape. Hit escape 2 times in between your commands. All right, so you initiate a command, you do the command. Once you're done with it, always hit escape 2 times right afterwards. And make sure that you don't have any active commands on. And it also ensures that anything you might have selected is deselected. So that way, when you start the next command, you don't start that command with whatever you accidentally have selected. It happens all the time. So escape, 1, 2. So there is the basic frame. We can't leave it like that. It's not structurally going to be very sound. If it were to have too much load on the top, or if it were to tip, it would turn into a trapezoid. So what we can do to prevent that from happening is we can insert a horizontal piece. So I'm going to select this top plate or the bottom plate, doesn't matter. I'm going to select it, type in copy. I'm going to zoom in, and I'm going to find this midpoint. Wait till you find the midpoint. And I'm going to find the midpoint of that bottom plate. I'm going to click it, and I'm going to move my cursor down until I find the midpoint of the vertical one, and click it. This is press enter when done. I'm going to hit escape, 1, 2, and that's a little bit better. That's a little bit more structurally sound. If I wanted to, I can also add in some K-bracing. A K-brace would look something like, let's rotate this from one of these views. You do not have to add a K-brace if you don't want to. I'm going to say copy it as I rotate it, and I'm going to rotate it from, actually let me move it up first. I'm going to move somewhere here. Oops. I'm going to copy it up. I'm going to rotate it. I'm not going to copy. I'm going to center from here to here and rotate it towards this corner. I'm going to need to move it a little bit so it's not in the way. And that's basically 1/2 of the K-bracing. And if I type in mirror, select this object to mirror, midpoint for the mirror plane, that's essentially K-bracing. Something like that. It's a little off, but I don't need you guys to worry about K-bracing. So now that I have that one wall done, I'm going to select each one of these studs, holding shift, and I'm going to type in group. So now that they're grouped, if I click away, I'm going to hit escape 2 times. If I select one of the studs, they're all selected. They're all a grouping now. It doesn't join them or anything. It just makes it easier for you to transport them. It's like they're all fastened together, they're all taped together, they're all bound together, they're grouped, right? I can always select it and say, hey, ungroup it. I need to change one of these. I want to delete that one. Okay, now select all these and group it. I can always do that. It's not permanently grouped. So now that I did all of that work to create this wall in Rhino that represents the frame CAD, I'm going to type in copy, and I'm going to copy it from this endpoint and move it to this endpoint, and boom, there's two, right? I could have done all that same work all over again, spend 10 minutes making that wall all over again, but if I just do it properly once and copy it over, I just saved 10 minutes. Next thing we want to worry about is this wall here. Before I move on, I want you to notice all of my corners, right? Each of these pieces intersect with one another. In terms of what we're doing here, that's okay. I don't need you to Boolean difference these things. I don't need you to figure out any joinery. These are all just boxes that are attached to each other at the ends. It's okay. When we go to 3D print it, it'll just come out as one solid piece. So it's not really a big deal. We're not even in FrameCAD Detailer yet. This is Rhino. This is us sketching out our ideas in a more formalized 3D environment. That is a significant upgrade from our sketchbook. We're still just sketching at this point. So notice that I have all of these pieces intersecting. That's totally fine. Oops. In fact, it's encouraged at this point. I'm going to group these again. All right, let's move on to the next one. So when we do another wall that runs perpendicular to a previous wall, we need to change the orientation of the studs. So I'm going to do another box, right click, 3-point box. And I'm going to come in here, I'm going to click on this endpoint, end of edge. I'm going to go this way, 1 5/8, enter. I need to make sure to click to let Rhino know I want to go this way. And then I need to define the height. I'm going to use this one to help me define that height, so I'm going to snap to that endpoint. And now I have the makings of the next wall. And that's what I mean when it runs perpendicular. It goes the other way. Okay. I'm going to select this one. I'm going to type in copy. I'm going to copy from this bottom endpoint. I'm going to copy to the endpoint over here and hit enter. Alternatively, you can mirror it. If I select that, type in mirror. The way mirror works is that you need to define an axis of symmetry, and it'll reflect it upon that axis of symmetry. So for start of mirror plane, I would select this midpoint of this curve that I had created a while back. And with ortho on, it's going to force me to create a straight line, and then that stud will be reflected or mirrored upon that axis of symmetry. So that's just a second way of doing that. Let's do our bottom plates. I'm going to click right here. I'm going to click right here. I'm going to click way over here. I'm going to click upwards 1 5/8. I notice that it's going the wrong direction, so I'm going to backspace and type in negative 1 5/8. Oops, not 15. 1-5/8. Okay, there's my bottom plate. I'm going to select that one. I'm going to type in copy. I'm going to select this top corner and move it all the way up here. So now I've copied it up. So there's four pieces of it. I'll go ahead and grab this stud. I'm going to type in copy. And I want to copy it from this midpoint. And I'm going to move it in this direction. Okay. If you need to, you can go way past the other object, so that way you don't accidentally snap onto the wrong thing. And I just want to say copy this way. And for copy 2, I want to say 24 inches. And that's where 24 inches would be. If I like that, I can go ahead and click once, and it'll put that copy right there, 24 inches away. And I'm going to hit enter to end the command. I'm going to hit escape 2 times to make sure I'm done with the command and have everything deselected. Looks like I need at least one more stud, so I'm going to select this stud, type in copy, and again, you don't even need to select any part of this piece of geometry. I could just copy from the midpoint with ortho on, go in the direction I wanted to copy to, type in 24, hit enter. If it looks good, go ahead and click, press enter. When you're done, hit escape 2 times, and that's the makings of the third wall. If I want to, I can also add the horizontal piece. Does anybody know what this middle horizontal piece is called? This one right here? It is called the noggin. It is a FrameCAD term. Noggin. So in looking at this wall, the very top horizontal stud, that's actually called the top plate. The bottommost piece is called the mud or sill or bottom plate. In terms of FrameCAD, it's called bottom plate. In construction terms, it's a mud plate, mud sill plate, or sill plate. In FrameCAD, it's called a bottom plate. The verticals are called sticks in FrameCAD, but in construction, we call them studs. But FrameCAD-wise, New Zealand-wise, you got sticks and noggins and bottom plates and top plates. All right, so let's go ahead and add a noggin. So I'm going to select my bottom plate, type in copy. I'm going to zoom in and I'm going to copy from the midpoint. And I'm going to move up and find the midpoint on this stick and click right there. Once I'm done, I'm going to hit enter. I'm going to hit escape 2 times and stand back, check out my progress. So that's looking about right. Now I can select each one of these plates and sticks and noggins. And what should I do with them? What do you think, Edith? Edith? What do you think? What should I do with them now? How? They're touching already. Unlock it? No, I want to group, just like we did with the other ones, right? We group them to keep them together, bind them together, tape them together, screw them together, so that way when we move one stick, we're not just moving one stick at a time. We can grab the whole wall and move it at the same time and be efficient. So group it. So I have 1, 2, 3 groupings. I have 1, 2, 3 FrameCAD walls. Okay. To add a little bit more realism, I'm going to select each one of these. And make sure you have the gumball on. This is the gumball, this red and green and blue thing. Down here in the status bar, it's called the gumball C-plane. Make sure that's activated. And then I'm going to click on the blue arrow. I'm going to type in 4 and hit enter. And it's going to move all of those pieces all at one time, 4 inches or 4 units in the Z positive direction, which helps me account for my caster wheels, which I'm not going to model. I could, but I'm not. I could. I might. But that's sort of where that's going to live, FrameCAD wise. So I'm going to change the name of layer 2 to FrameCAD. Oops. I'm going to change the color to something grayish. I like this bluish grayish color. Choose whatever color you want. It's just a display color. It's just to help you differentiate between your layers. So I know, oh, that's on the red layer, that's on the gray layer, that's on the blue layer, that's on the green layer. Really has nothing else to do besides that. And then the next thing I want to do is I want to start to think about how I'm going to sheath this thing with plywood. So I don't want to give her a cash wrap that's just made out of frame CAD and call it a day. I need a top, I need some sides, maybe I want some shelving. So I'm going to go to layer number 3. I'm going to make it current by clicking in this column where the check mark is on the row called layer 3. I'm going to rename layer 3 to plywood. For a little added extra little bit of realism, I like to change my layer colors to somewhat reflect the things they're actually trying to portray. So for plywood, I'm going to choose this brownish, tannish color. You don't need to necessarily do that to be good at Rhino, but I just want my 3D model to kind of make sense to me without me having to render it. I'm not interested in rendering this at the moment. I'm just sketching. I am continuing to pursue my idea and make decisions about the design. I'm not worried about making it look super pretty for my Instagram yet. So now, with the plywood, who can name a tool, a command that I can use to emulate the plywood? What would be a good command I could use? Box. One of the few commands I've used today, right? I've used copy, I've used box, I've used polyline or rectangle and offset and move. That's it. I've used like 10 different commands today, right? So if you think about a sheet of plywood, it's just a box, right? It's just a very thin box. So I'm going to right click on box, right click on this box, click on 3-point box, and let's go ahead and put it the start of edge at this end point, end of edge at this end point. I'm going to move in this direction. I think we'll probably end up using 1/2 inch plywood, so I'm going to type in 0.5 inches. Again, if I want to be the super nitpicky, controlling type of designer that everything has to be exactly the way I've designed it and measured it, I can go and grab my caliper and figure out exactly how thick the plywood is that I'm going to use. Every sheet of plywood has its own unique thickness too, so I'm not sure how much effort and energy I want to go into to do that, so I'm just going to say 1/2 inch. It says choose rectangle, I'm going to go this way. And then height, I'm going to come over here and snap to this point here. Or, alternatively, I can go past that point, right? If I snap to this point where it's exactly at the bottom corner of the frame CAD piece, you're going to see those caster wheels below, right? And that's why some of you want to design what we would call a skirt around the cash wrap. The skirt visually hides the caster wheels from view, right? They're still there, they're just harder to see. Now the frame CAD, we don't want to see it. It's so ugly. The caster wheels, we don't want to see those either. They're so ugly, right? We want to see the beautiful plywood. So when I snap to this endpoint, if you look down in the bottom left of the status bar, just down here, as I snap to that endpoint, it says 2 foot 7.5 inches, which is 31.5 inches. I know that it's going to take another 4 inches to hit the 4.5 inches to hit the ground. So I don't want my plywood to go so far that it's touching the ground, right? Because then it's going to be very hard to move this thing. It's going to be scratching on the floors. So let's say we go to the bottom corner of the frame CAD, and let's add 3 inches. So 2 foot 7.5 is this dimension. So if I type in 2 foot 10.5, Oh, whoops, went the wrong way. If this happens, all you have to do is select it, type in move, find this endpoint, find this endpoint, and there we go. Okay, so that amount that it's sort of floating in the air relative to my grid or my construction plane helps us visualize this skirt. It goes past the actual frame CAD structure to help hide those ugly caster wheels. Okay. Now, if I don't want to go through all that work of making that box again, what would be an easier way for me to cheat and create the same thing over here without doing that box command? Copy. Copy works. What's another way I could do it, Josue? It's been taken. Try again.
Mirror?
Yes, mirror. So I could copy. So here's copy. Come here, zoom in, select my plywood, copy. I want to copy from this endpoint. Click. Come over here, copy it to this endpoint, enter. Okay, that works. Or mirror. Select the objects to mirror. Find my midpoint. Create an axis of symmetry. Same thing. Some commands can actually increase your productivity. Some commands allow you to do the same thing with like one less step, which in the end saves you like 0.2 seconds of juicy time for designing. And once you add up all of these 0.2 seconds from all the time you're saving from being super efficient with all your commands, by the time you're done 3D modeling this thing, you probably have a whole 1 second of time that you saved. So, next thing I want to do is let's add some more plywood. Let's use the box. I'll snap to this endpoint. I'll snap to this endpoint. I'll snap to this endpoint. I'm going to go in this direction, 0.5. Click. Looks like it's gone the wrong way. No problem. I will move it from here to here. Escape, escape. Okay, that's what my box is looking like now. So now, how do I want to do the top? Let's say I do a very basic top. I'm gonna do another box, and let's think about like not even having any overhang. Let's say it's just right here. So I'm going to click here on the endpoint, click on this endpoint, go to this endpoint, go up 0.5, hit enter. There you go. I could be done. I could be done with that. Okay, here's what the structure looks like. It's floating right now because it's got caster wheels. So I'm not going to model those caster wheels, but am I happy with that? Does that look good? I don't know. Kind of. It's not bad. It's just a big plywood box, right? It could be cooler, right? And that's where we need to go back to our sketchbook, right? Go back and forth. Like, all right, that's what it looks like. That's not what I thought it was going to look like in my book. So let me go back to my book, take this image, come up with some new strategies, some new ideas. What if it actually was wider? So let's go ahead and I'm going to delete that. I'm going to do another box. I'm going to do the box way over here. Start of edge, end of edge. So let's think about how, if we had it overhang, if the countertop or the top of this cash wrap overhang, just like this teaching station does, how much should it overhang on each side? What do you think, Colton?
I'd say like a half inch to an inch.
An inch? So in the front side, overhang 1 inch?
Yeah.
Okay. So we know that the current overall depth of our cash wrap is 24 inches. So if the top overhang 1 inch, it would be 25 inches. So end of edge, 25, enter. And then I want to click in this direction. Now let's determine the width. So I know that currently the design is 6 feet wide. And hello. No problem. I know it's 6 feet wide. So Josue, how much should it overhang on the sides? Should it overhang the same amount on either side? Should it overhang more on one side? Should it overhang at all? We're doing the top, this part of the teaching station, the part where I put my laptop and I lean and I have my coffee on. Do we want it to go past this? No? No? Does this one go past this?
The slightest bit.
The slightest bit?
Extend it too far.
You wouldn't extend it too far. Okay. So what would that distance be?
Probably like
Half an inch? On each side?
I think so.
So 0.5 plus 0.5 is 1. So if overall my width is 6 feet, I would type in 6'1" and click in this direction. And then the thickness of my material is a ½ inch. All right, there's my top. Let's move my top onto my cash wrap. I'm going to type in move. I'm going to say move from, and I'm going to find my midpoint on the bottom edge. There's my midpoint. I'm going to click that, and I'm going to come over here and find the midpoint. Okay. Now I have it overhanging on the back end, which is not what Colton wants. You want it to overhang on the front, right? So I need to move it a little bit more. I need to shimmy it over from here to there. Actually, sorry, not like that. I just shifted it diagonally. Let's just move it this way. What did we overhang it? 1 inch? 1 inch. So I'm going to use the gumball, move it this way 1 inch. Uh-oh, what's going on here? Now it's underhanging over here. I might have done it twice. 1 inch here to there. Oh, I forgot to account for the thickness of the plywood. So the frame CAD component of this project, the structural component is, the overall width of the structural stuff is 2 feet by 6 feet. Plus I have plywood on top of that. So I have to add another ½ inch on left and right sides and another ½ inch on the front side. Does that make sense? Does that make sense to you guys? Let me go backwards. When I drew this rectangle down here, oops, this one down here, that rectangle was 2 feet by 6 feet, correct? Correct? Okay. Okay. And then I modeled the frame CAD, right, off of that, right? So that's the frame CAD. It's lined up to the edges of the rectangle. I put the plywood outside of that boundary, right? which is what you would do in real life. When we draw these architectural plans, the structural component of the building takes precedent of the overall dimensioning of the project. Because when we start to make a building, right, we start literally with the foundation, right? That foundation would be this 2 foot by 6 foot outline, right? That would be your concrete slab. Your steel sits, your structural posts sit directly on top of that slab. They don't overhang it, the slab doesn't underhang it or overhang it. And then once you start to put your finished materials on either side of the wall, they come out of that shape. So the overall structural width and depth was 2 foot 6. The frame CAD portion, if I was to take a measuring tape and go from this end to that end of the frame CAD, that would be 6 feet. So let's type in distance to measure. Measure from this end point of the steel to that end point of the steel, that is 6 feet. And then each sheet of plywood sits outside of that boundary. Okay? So when I did my countertop, what I should have done was measure first. So I'm going to type in distance. The measurement from this end to this end is 6 foot 1. So Josue wants it to overhang a ½ inch on the left and on the right. So what would that overall length of the top be if you wanted to overhang ½ inch on either side?
6 feet, 1 inch?
No. It is currently, if I measure from the plywood to the plywood, it's 6 foot 1. You want it to go past that, ½ inch on the left, ½ inch on the right. So when I go and cut that piece of plywood, what length would it be?
It would be 6 foot 2.
6 foot 2, exactly. And then if I take my distance command and measure from here to here, that is 2 foot and 1/2 inch. Colton wants 1 inch overhang on the front, so that's a 2 foot 1 inch, 2 foot 1.5 inch overhang, or 2 foot 1.5 inch depth of that piece of plywood. So let's do box, right click, 3-point box. Start of edge, end of edge is going to be 6 foot, what was it again, Josue? 6 foot 2, thank you. 6 foot 2, enter. Click once. And then the overall depth of that top was what again, Colton? What was the overall depth of the countertop? What was it? Say it again. 5 inches? No, this amount. 5 inches? 25 inches. 25? Wait, what? 25.5. Okay, sorry. So 25.5. Enter. Click. And then upwards, ½ inch. All right, that's the correct size. Now I can take this, type in move. Move it from the midpoint on the bottom edge. Find the midpoint. There it is. And then move it over here to this midpoint. And then I need to scooch it. I need to scooch it forward 1 inch. And that should leave it flush on this side. No overhang for Colton, for his employees. No overhang over here. 1 inch overhang over here for all the customers. And then my ½ inch of overhang on the left and right for Josue. That's how he likes it. So I like it. So that's the top, that's the sides, that's the frame CAD component. I can develop this further. I can import some imagery. I can put some text on this. Let's say I come in here and Let's go to front view. I'm going to turn on shaded mode in all 4 of these viewports. I'm going to zoom in into all of them. Let's go to my set view. Let's go to the back. Let's type in text object. I'm going to choose solids. And instead of my last name, let's type in Coast Collective. I have this fun font that I had downloaded for something else. Let's see, let's make the height of the letters 6 inches. I'm gonna type in, I'm gonna move that down. Let's call it OCC Coast Collective. Click OK, and then put it right here, smack dab in the center. Okay, where did it go? Oh no, it disappeared. Don't worry, it's just hiding back here. Let's put it on its own layer. We'll call this letters. Okay, I need to move this over here to the front. So from this view, I know that I can move it from here. Currently it's sitting at a y is equal to 0, right? This is my y axis, actually this is my y axis here. So if I were to move it, I need to move, and I'm going to move it this way, 2 foot 0.5 inches. Okay. Does that look good? It looks okay. I think it looks okay. But it could be developed further. That's your job. For now, this works. So this is the end of the 3D modeling portion of the design at 1-to-1 scale, right? 1-to-1 scale means that 1 inch in this space is equal to 1 inch in real life. So this is a 1-to-1 inch scale, or 1-to-1 scale. So moving on for the next portion of this exercise is I want to hold this in my hands. Now, you can do this manually by getting some materials, cutting it, getting your knife, getting a straight edge. You could do that. That's totally fine. I'm going to show you how to do it easily through 3D printing. Okay? So, pay close attention. I'm actually going to turn off the plywood. I'm just going to 3D print the frame CAD. I'm going to turn off these letters. I'm kind of only interested in the frame CAD right now. So I'm going to select all of my frame CAD. Actually, I'm going to move my curves, all these curves down here. I don't want to delete them. I'm just going to put them on another layer. I'm going to name that layer curves so I remember where they are, and then I'm going to turn them off. I don't need to see them anymore. I'm just going to worry about these panels. Okay? In FrameCAD, when you assemble all of these sticks and horizontals and noggins, instead of calling them walls, FrameCAD likes to call them panels. So each of these walls are panels. Walls equal panels. And what I'm going to do is I'm going to select all of these, and I'm going to make a copy. So let's type in copy. And I'm going to copy from here to there, hit enter, hit escape. I'm going to make a new layer called 3D print. I'm going to select these 3 groups of panels. I'm going to change object layer to 3D print. Let's choose something super bright and red so I can tell the difference between the two. I'm going to make this 3D print layer active or current by hitting the little check mark here in this column. I'm going to hide the other one. Now I can just focus on this one here. I've made a copy because I'm going to scale it down, right? And I'm going to scale it down to 1/2 inch is equal to a foot, right? We have a physical model that Amy and Albert have been working on. The architectural scale of that model is 1/2 inch is equal to a foot. So if I were to make a model, it probably should match that scale, so that way I can put it inside of the model. Now I'm going to take each one of these pieces, holding shift, and this is the way I like to scale. I'll do it from here, but I'll leave it in all 4 viewports so you guys can see it. When I go to scale something, this is my very specific way of doing it. And to me, it makes a lot of sense. But it's very foreign to everyone else. I make a polyline. I actually make 3 polylines. So I'm going to draw a polyline from 0 with ortho on, and I'm going to go straight up in the air. Doesn't matter how long it is. Sometimes I like to make it super extra duper long just so I know I can delete it later. So I'm going to click here. I'm going to press enter to end the command, hit escape 2 times. I just have one big long line. I'm going to type in offset, hit enter, hit D for distance, and I'm going to type in 12. I'm going to select this curve, and I'm going to say I want to offset this way, to the right. You can go left if you want to, but you have to stay consistent. So I'm just going to go right, 12 inches. I'm going to click. All right, now I have 2 lines. Now I'm going to offset one more time. Press enter. D, press enter. I'm going to change the distance. The distance I'm going to change it to depends on the scale of the model that we're creating as a physical model. It's 1/2 inch. So I'm going to type in 0.5 and hit enter. Oops. I'm going to select that first line that I drew. I'm going to hover my cursor to the right side to stay consistent. And I'm going to offset that line 0.5 inches to the right. So now I have 3 lines. I'm going to select all 3 of my groups, all 3 panels, and I'm going to zoom back into all 3 of these lines. And I'm going to type in scale. Scale. Press enter. Now my base point, you make sure you have your O snaps on. Make sure you have end, near, point, mid, center, intersection, perpendicular on. And my base point, I'm going to choose a near point on that first line on the left. Okay, so I'm going to zoom in a little bit tighter so you guys can see that. I am on the near point, which is really just any point along that line, but it's touching that line. I'm selecting a near point on that first line. That's my base point. Click. The scale factor, or first reference point, I'm going to zoom out. I'm going to hover my cursor all the way to the right-hand side for that line all the way 12 inches away. You should be able to snap to a perpendicular or intersection point. If you don't, make sure your O snaps are on. Okay, once you find it, click. And now my second reference point, I'm going to hover my cursor over to that other line. Sometimes you got to zoom in to get it right. And I want to find the perpendicular or intersection point of the second line. Okay, so we went from the left line all the way to the far right line, now to this line in between the two. Make sure you're snapping to the line, not the actual FrameCAD panels. Make sure it says perpendicular or intersection, and then you're going to click. Okay, so now looking in perspective view and front view and back view, my frame CAD disappeared. Where'd it go? It's right here. So tiny. All right. Let's turn on the frame CAD layer. That's my frame CAD layer. That's real frame CAD steel over there. This is my little itty bitty teeny tiny little model right there. I can't even zoom into it. Okay. So that's how you scale. So let's review that. I drew 3 lines, one on the far left at the 0 datum. It doesn't have to be at the 0 datum, but let's just call it that. I offset that line 12 inches, and then I offset that same line, that first line, a ½ inch. And then when I went to scale, I said scale it from that original line to this 12-inch line and make it this instead. And I went to that third line. And basically what I said was, anything that's 12 inches, make it equal to ½ of an inch instead. So that's why now my frame CAD has been shrunk to a very teeny tiny little size compared to its original size. And that's how I scale to an architectural scale for 3D printing, for creating a physical model, for laser cutting. That's how I get the correct scale. That is one way of doing it, and that's my preferred way that I've learned over the years. It is not the only way. So now I'm going to delete these 3 lines. I don't need them. I just needed it for scaling. I'm going to turn off the frame CAD layer. I don't want to see it. I don't want to mess it up. I don't want to touch that part. I want to work on the 3D printed stuff. Okay. It's so tiny now, I need a magnifying glass. So I'm going to select the 3D print, type in ZSA, and now I can fully see it. ZSA is zoom, select, all. So whatever you have selected, it'll zoom into it in all of your viewports. ZSA. If you've ever had that issue where you're trying to orbit and pan around your model and then you try to zoom in so far that your camera just whacks out and it disappears, select your item, type in ZSA, and it will zoom into that selected item in all viewports. Very, very important command. Okay, so there it is in all 4 viewports. I'm fully zoomed in. If I look at it in top view and I just grab it, use the gumball to just move it all the way down, this grid is something I can use to gauge how big things are. So each one of these major grid lines, the thicker lines, that represents an inch. So each one of these large squares is 1 inch by 1 inch. Each one of these little tiny squares, or minor grid lines, are 1/4 inch. So every little tiny square is a 1/4 inch by a 1/4 inch. So in looking at this model, now it is 1, 2, 3 inches big. It used to be 6 feet big. Now it's 3 inches big. Which means if I sit and do the math a little bit, every ½ inch is equal to a foot. It's 3 inches long now. So ½ inch plus ½ inch is 1. 1 plus 1 plus 1 is 3. So 3 inches is 6 feet. So now that I've got it scaled down correctly, ZSA, now I just want to prep it for 3D printing, and that's going to be the easier part. I want to lay all of these panels down. When we 3D print, the extruder of a 3D printer is typically pointing downwards. You have the bed plate of your printer bed, and plastic filament is fed into the extruder. The extruder heats up that filament to melt it, and it'll come in and melt it perfectly to create your model. Typically, you want to lay things down flat as best as possible when you go to 3D print, right? We shouldn't 3D print the wall like that, so it goes beep, 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 and go all the way up like that, when we could just lay it down and it could just do that with ease. So we're going to rotate all of these so that way they're all laying down. I'm going to use a command called rotate 3D. This is not the only way to do it. I'll do it in a couple different ways. So for rotate 3D, you want to start a rotation axis. You want to define an axis in which it is hinging upon. Okay, so if I snap to my endpoints from here to here, okay, and now I need to start to define how it rotates. I'm going to say first reference point is here, and I want it to fall downwards like that. So it's hinging off of that first line that I referenced, and then I'm saying fall from here down to the ground. That is one way. Another way is you can select your wall, your panel, and use the gumball. If the gumball is not active, make sure you activate it here in the status bar. And I'm going to use this red arc and click and drag and rotate it. And now it's rotated 90 degrees. I was able to easily do that because ortho is on. If I turn ortho off and try to do that, it's going to allow me to rotate it in whatever degree that I want. I can hold shift to constrain it. Holding shift is basically a temporary ortho on and off, but I'm going to undo that. I just usually have ortho on and rotate it. Problem with this method is, the problem with this method is once you rotate it using the gumball, it's floating up in the air. But you can simply type in move and move it right down here next to the other piece. So let's rotate this guy. I'm going to rotate it like that, and then I'm going to move him and put him right here. Okay. Remember, they're still floating in the air, technically, because when we had 3D modeled our cache wrap, we accounted for our 4-inch casters, so they're still up in the air. So I'm going to select them all, type in move. I'm going to move it from this bottom endpoint to the origin. Whenever you're fabricating with design tools like the laser cutter or 3D printer, wherever your geometry is relative to the origin will appear in those technologies as well. So when I go to slice this for 3D printing, it'll be dependent on its relativity to the origin. So from here, I'm going to go back here like this, and they're all touching each other. I don't want them to touch each other because if I print it like this, they'll all be stuck together. So what I'm going to do is I'm going to select this one and I'm going to move it somewhere over here, so that way they have a little bit of a gap. I'll move this one over here. I'm kind of bunching them up together. Okay, this is now ready for me to export. So I'm going to save my file because I haven't saved at all today. So I'm going to say File Save. Make sure you guys are saving your files in the correct spots. I'm going to put it here under Assignments. Make sure you give it a good name, 250709. This is assignment 12. 13, thank you. And this is going to be a cache wrap model. Initials, TJC, for me. I'll save it as a Rhino model, okay? When you save your Rhino models, the file type of a Rhino model is 3DM. Okay. When we design, we're in Rhino, and this is a 3DM, .3DM file type. Remember that. I'm going to hit save. Now to get to the next part, before we actually go walk over there to the 3D printers, we need to export this out of Rhino as a very specific type of file. So it's currently a Rhino file. We need to take the things that we want to 3D print and export it as a different file. Does anybody know what kind of file type you need to export it as? Any ideas? Nobody. We need to export this as an STL. So I'm going to type in export. It says select objects to export. I'm going to select this one, and this one, and this one, and press enter when I'm done. I'm going to search for the place that I want to put it. I'm going to put it in the same place. I'm going to give it the same name. And I'm going to look for Save As Type STL. Okay, that stands for stereolithography. So this next part is called slicing. We were designing in Rhino and in our sketchbooks. Now we are slicing. And from Rhino, we need to export our objects as a .stl. .stl. Make sure you have that written down. Okay, give it a name and save it. Put it in the right location. Hit save. You're going to hit OK for each one of these dialog boxes. Next step, Bamboo Studio. You should have Bamboo Studio located on these computers here. If you have your own personal computer, you can download Bamboo Studio. Most slicing software are free. Not all, but most. Slicing is the process of determining how that 3D printer is going to create your print. Making sure that it uses the right settings, the right heat, the right filament, the right supports, all that stuff. We slice our projects. So as we slice it, we're in Bamboo Studio. You're going to create a new project. For your first time using Bamboo Studio, you will need to choose the correct printer. That's dependent on what printers are available to you. Here in Architecture and Makerspace, we have only one type of Bamboo printer called the Bamboo Lab P1S. So if you don't have that option here, you can click in this area, select/remove a printer, and just select Bamboo Lab P1S 0.4 mil nozzle. Okay. You do not need to select all of these other options, because then you'll just have all these options that you really don't have. Bless you. We don't have any of these other printers. So if you have one at home, then definitely add one of the other ones, but we have a Bamboo Lab P1S 0.4 mil. Okay. Make sure you guys write that down. Slicing.stl Bamboo Studio, new project, import STL. So that's the next part. Once you've added the printer, you're going to hit confirm, file, import 3MF, STL, STP, SVG, OBJ, AMF. You're going to select that option. You're going to find your STL file. I put mine in this folder here. I gave it this name. Okay. Now, when you're slicing, typically, these slicing softwares, those 3D printers, they think in terms of metric. Most of the world thinks in metric. Not here, not in America. We like fractions, right? We like quarter inch, eighth inch, 16th, 32nd, 64th, 128th, 256. What's after that one? 562? Something, yeah. Okay. But the rest of the world uses metric. Mexico, Canada, Europe doesn't even use imperial, right? We don't even have an empire, but we use imperial. Okay, so when you're importing your STL file, it's going to tell you, hey, I'm importing it right now, and it looks a little small. Are you sure this is the right size? Do you want me to scale it to millimeters? Basically, we know that it's 3 inches wide in Rhino, right? When we scaled it down in Rhino to 1/2 inches equal to a foot scale, I measured it. I know that the length of it is 3 inches, right? To the slicer, it's just reading 3 units. And since it prefers millimeters, it's seeing it as, it's only 3 millimeters big. You guys know how big 3 millimeters is? Yeah. It's like that. Right? So I'm going to say no. Don't scale it. The answer is yes, but I'm going to show you guys what happens when you say no. It's like, okay, fine, here it is. It's even tinier than it's supposed to be. It's like a tiny version of the tiny version. It got shrunk twice. Okay, wrong. Okay, if you guys look at the Bamboo P1S printers, you'll know that this plate that we're looking at here in the slicer, it's like about that big. I forget the exact dimensions, but it's that big. So it's saying that my model is 3 millimeters that big. Wrong. Sibley is not going to be happy with that. So let's start over. I'm going to start over, file, new project. No. File, import. Find my STL. This time I'm going to say, yeah, can you scale it to millimeters? Yes. And that's what it should look like. Okay. Still small, but not too small. It's very important that you get these measurements right. Because architecturally, we have to conceptualize our projects to scale. We have to be able to show our clients these projects to scale. Not like, this is what it looks like. There's no real scale, but all right. Enough with that. So Bamboo Lab P1S is my printer, 0.4 nozzle. My plate type is textured PEI plate. I'll explain it to you once we get to that point. Filament, we actually have what's called the AMS, which is an upgrade to our P1S. It allows us to have up to 4 spools of plastic filament on top of the 3D printer, and we can print with all 4 of those colors. We can do white, red, blue, green, whatever we want, whatever colors we happen to have. So this print, I could say bottom part black, let's put a little bit of blue in the middle, let's do some red on the top. But for us, generally in the architecture, we want our designs to be in white or monochromatic. So if possible, we're going to go look for a white filament when we go to print this. Not a huge deal if we don't have enough white. I'm going to advise that you keep all of these settings just the way they are. Okay. If you click right here under Process, these are what are called system presets. Okay. So with the Bamboo P1S, these are all just recommended settings depending on how fine of a print you want. Starting at the top, 0.08 millimeter extra fine at BBL X1C. Each of these numbers in this left-hand column represent the layer heights. So when we 3D print, we're 3D printing one layer on top of another, on top of another, on top of another. The finest layer height that we can have is 0.08. That means every layer is very tiny. Every time it moves up, it only moves up 0.08. Okay? When we do it something that fine, it's going to take longer. On the other end of the spectrum, 0.28 millimeter extra draft is going to give me big, fat, chunky layer heights. It's going to be like, okay, here's one, here's one, here's one, making it go extra fast. So if we just need it in our hands right away, if our meeting is in 30 minutes, we might want to choose that one so it just prints it right out. Now somewhere in the middle is just your in-between. So I'm going to select 0.20 millimeter standard. For a project like this, with that preset, it's only going to take like 30 minutes, if that. So 0.20 millimeter standard.
Is the quality better if you use thicker or thinner?
The quality is better when you use a smaller layer height, right? It's going to be like with a 0.08 millimeter, it's going to be 0.08, 0.08, 0.08, 0.08, 0.08, 0.08, all the way until it gets to the final desired thickness or height of our project. If I say 0.28, it's going to do 0.28, 0.28, 0.28. So let's do it. I'm going to show you real quick. 0.08, let's choose the 0.08 system preset. And what those presets do is all of these properties are already by default assigned for each of these presets. So I don't even have to touch any of these unless I want to have further control, or I notice in my print quality it's not that great. I might want to adjust some of it, but some of these presets are just perfectly fine. I'm going to slice it for you just to give you an idea. So when I slice it with the 0.08 mil extra fine setting, I'm going to end up with 46 layers moving in the upward Z direction. So it's laying on the bed. It's going to take 46 layers to get my little scale model printed. 46. Keep that number in mind. 46. On the other end of the spectrum, instead of 0.08, let's see what it looks like when I do 0.28. And I slice that plate. What was my other number?
46.
How about 14? Should we do 14 instead? Depends on how much of a rush we're in. All right? So that's the difference from one end of the spectrum to the other. And obviously, if it's going to do 46 layers, it's going to take longer, right? It's got to go around loop-de-loop 46 times. If it goes loop-de-loop only 14 times, that's not going to take very long at all. So that's the difference. I'm going to choose something in between. I'm going to choose 0.20 millimeter standard. Make sure you guys write that down. 0.20 millimeter standard. New project, import STL. Scale, yes. Bamboo Lab P1S. I'm writing these notes down for you. Bamboo Lab P1S, 0.4 nozzle. And then 0.20 millimeter preset. And then the next step, slice, plate. If we had more items to add to this project or for this print, we would add more, import some more. However, I'm done. So once you're here and prepare, you can choose the correct preset and slice plate. Okay, once you slice plate, it slices it for you in the upwards Z direction. And with this preset, it's going to be 19 layers. So not that much more than the extra draft layer, which makes sense because it's actually relatively close to that extra draft setting and further away from 0.08. So it's going to take 19 layers. In this top right corner, it's also giving me so much more information. It's like, all right, total filament that you're going to use is 60.25 inches linear length of filament. It's going to cost 12 cents. It's going to take me 14 minutes and 10 seconds to print this. Lots of good information. Once we get into FrameCAD, FrameCAD is very similar in that way. It understands exactly how much material it's going to take to create what we want to create with FrameCAD. And it has an ETA, and it tells you how many fasteners you're going to use. It is fascinating. Now that we've sliced plate, you're going to click on the drop-down arrow next to Print Plate, and you're going to click on Export Plate Sliced File. Okay, Export Plate Sliced File. Okay, we can't print plate. Print plate is if you're connected to the Bamboo P1S via wireless connection, which is very typical. If you own the 3D printer, it's at your house, and you have a computer, and you guys are both hooked up to the same network, you can just say, hey, print it now. Okay, because we're sharing it in the architectural space, we're sharing it with the makerspace. We're not all hooked up to it wirelessly, so we need to instead export plate sliced file. Once you click that, you will now have the option to export plate sliced file. And this file that you are now exporting, the file type is .gcode.3mf. Okay, that's very important. I want you guys to grasp that concept. I've already mapped it out here. I'm running out of space. I should have started on the other side. Export plate slice file. .gcode.3mf onto all right, so I'm going to name that file as I always do with the correct file naming scheme as my instructor has asked me to. And this file, you want to put it on a micro SD card. Where do I find a micro SD card? If you go over to those 3D printers, and I'll show you in a little bit, there is a teeny tiny little micro SD card all the way at the top. You're going to eject it, grab that little teeny tiny micro SD card. You need a very special adapter, so that way you can, this one, I think this one can do it. This adapter allows you to take a teeny tiny micro SD card, you put it in there, you connect this to your laptop or your PC, whichever one you're using, and then you save your G-code file onto this micro SD card. It's like a flash drive, same thing as a flash drive, just a For some weird reason, they wanted to use a micro SD card. Okay, so you're taking your G code file, you're saving it. You're more than welcome to save it onto your own computer. You're more than welcome to save it onto your own flash drive, just in case you want to print this again somewhere else. But from this point on, you want to save it onto the micro SD card. I'm going to leave it right here under assignments and hit save. And then you want to eject the micro SD card from your computer, and then you're going to walk that micro SD card to the 3D printer, put it in, say go, and come back in 14 minutes and 10 seconds. All right, that was a lot. We designed our cash wrap in 1:1 scale in Rhino. We scaled it down to 1/4 inch is equal to a foot. We just learned how to slice for 3D printing, and we're also going to 3D print today. That was quite a lot all in one live lecture. I do hope the audio recorded. I want you guys to come over here and grab a snapshot of what I've written on the board outlining each of these steps. It's very important to understand and conceptualize the journey from Rhino all the way to holding that model in your hands after it's 3D printed. 3DM file, export to STL, open Bamboo Studio, import STL, slice it, export G-code. G-code goes into the micro SD card, and then hit print, and then you hold it in your hands in 14 minutes and 10 seconds. That was a lot. Does anybody know what G-code is? G-code? What is G-code? You don't have to guess. If you don't know, it's okay. What's G-code?
I'm guessing it's the coding that the specifically
Yes. Essentially, what G-code is it's a set of instructions, a series of instructions that you create that dictate how the digital tool will create your product. It is a set of instructions, basically. Let me see if I can open it up here. I'm guessing none of you have ever seen G-code, but let's see if I can open this up in Notepad. Oh, kind of. All right, this looks like alien language, but let's go export plate, slice file. See if, no, I can't do anything else. Let me find another example of some G-code. I've written G-code. I've taken a CNC class, so I got to write some G-code recently. So let's go to summer. Let's go to CNC class. Here we go. All right. So this is an example of G-code. I wrote it myself, every single line of programming. And basically what it is I'm telling the machine to turn specific tools on. I'm saying, hey, go grab tool number 2, move to this point. Here is the tool length compensation. Approach the piece, cutter comp. It's a bunch of lines of code that instruct the machine exactly where I want it to go and move. So what slicing is you're saying, here's my 3D model, make me G-code. I don't want to write the G-code manually. You write it for me. And then what the G-code does is it tells the 3D printer, okay, take your nozzle, grab filament, heat it up, put it inside the extruder, and move like this 19 times in the upwards direction. And when you're done, just put the tool away, lower the bed, lower the temperature of the bed, and then somebody will grab the piece. That's what G-code is. Way beyond this class. All right, question time. Any questions? That was heavy, but relatively easy. Yes. Got it. No problem. Any general questions about what I just went over?
Is it going to be printed separately, or is it going to have like a little kind of attachment so that you can kind of like break it?
So it will be separate in terms of the way I've put a little gap in between each of these three groupings of panels. But the way I've modeled this thing here, with the way these boxes all intersect with each other, that's actually going to come out as one singular piece. I can break it and have separate pieces, but it's just going to be broken. But it's not going to give me individual sticks or boxes or anything. It sees all of this thing here, and it's like, oh, I just see one solid thing. I don't see 1, 2, 3, 4, 5 boxes intersecting each other. I just see one unit.
So it's kind of like those airplane ones, so that's like all in one sheet, and then you can.
Kind of. That's injection molding, but yeah, kind of.
And why is it better to print it out this way, or print it out like just in separate pieces, like 3 separate pieces?
Like 3 separate plates?
Yeah.
Well, let's look at it. I can fit them all in one plate. So why would I want 3 separate plates, 3 separate printers? Do you own 3D printers, 3 of them? No. Would I want to do like one print at a time and wait 15 minutes for each one? Or to just say, hey, print them all. So you can fit them all, and if you can fit them all into one plate, I would just print it at one time. That'd be like asking the printer, like, hey, I need to print this entire textbook online. Print me one page. All right, and then you go file print. All right, now print this page and file print. Okay, now print page 3. Okay, and file print. Right? I could say, hey, file print all, and just wait.
Print it all just the 3 pieces all at once, like separate. Like you said that they're going to be all in one sheet. What do you mean by a sheet? Like that whole sheet?
This is a plate.
Oh.
Yeah. Yeah, if you go look at the 3D printers, the 3D printer will actually print it onto something. It's called a plate. Yeah. It doesn't print it in the air. It's like, hey, Edith, I'm just printing it. I'm going to spit it towards you. Just stay right there for 14 minutes and 10 seconds. No, you just...
I just sound like completely new, so I'm curious, I guess, how the printing works.
Yeah, get this done quicker so you can actually see it. That's going to be done today. You guys are going to 3D print today. You should at least start your 3D print today. That's where I want to get us. So, big news. Next Wednesday will be our final presentation to Sibley for this project. So we need to have this done. So by next Wednesday, we're going to give her a presentation. You're going to present your design. You're going to defend it. You're going to sell it. Hey, Sibley Sabori, hello, how are you today? You look beautiful. My name is Edith, and this is the perfect solution because 1, 2, 3, 4, and the reason why Josue's is the wrong solution is mine does this, mine does that, mine has all this capabilities, mine is the most superior one here in this room. So choose mine, right? And then Josue is going to come and present. He's going to be like, well, sorry about that. She's out of her mind. She's had too much coffee this morning. Let me tell you what the correct solution looks like. And it looks like this and this and this and this and that. And you're going to tell her about all the features of it whilst giving her an idea with the physical model. Okay. So we're going to sell our idea. So we need to have that physical model done no later than Tuesday. And then probably Monday we'll take a look at creating a very basic presentation layout, so that way we can present our ideas without her having to imagine it. We're going to give her visuals, we're going to give her a physical model, we're going to give her a written description of things, we're going to point out specific features in our design and how we're addressing her comments that she's given us. Right? Just like you do in the real world. We're constantly making presentations. I'm always ready to make a presentation. I'm always ready to defend my design. So next Wednesday, write that down in your books. Next Wednesday, presentation with Sibley, 8 a.m. So don't be late. Have your physical model done the day before, because you will not have time to print it during the presentations. Monday is an important day. We're going to look at how to create our presentation boards. You may need to spend some extra time on this. I am here today. I have class at 1 p.m. to 4:30 with my fabrication students. We're 3D printing, we're laser cutting, we're CNCing. You may stick around and work on the project. I will also be here tomorrow at 8 a.m. till 6 p.m. and I'll be here Friday, same time, to help you guys get this done. All right. Any other questions? All right, get to work. I'm gonna use the restroom and take a break and have some coffee. There's some more coffee, I think, if you guys want any. And good luck. Help each other out. I'm gonna end my live stream. It should be ready to view very soon. I don't think it's instant, but once I end my live stream, it should be available on YouTube. Mm-hmm.
I have a question about layers. I still don't know how to say different layers.
Letters?
Yeah. How to say different layers.
Oh, layers. Layers. Yes. Okay. That's a good question. So I have, when you start a Rhino file, it always has 6 default layers. That comes with each template. You have the default layer, and then layer 1, 2, 3, 4, 5. If I want to be in a specific layer, you see this check mark? You see the check mark? This one right here? Check. You see the little check? I need to find, this is in a column, right? And depending on what layer I want to be in, if I want to be in the curves layer, I need to click in that column where the check mark is. And when I do that, now that layer is bold. I'm in that layer. So now anything I draw here will be in this layer.
Oh, okay.
Okay. Or if I need to change something and move it to that layer, I can select that item or object. I can come here, right-click the layer, and said change object layer. I want to change this from the red layer, which is 3D print, and I want to change object layer to curves or whatever layer, and I say change object layer, now it changes color. The color corresponds with the display color of each layer. So curves is white, letters is green, plywood is brown, FrameCAD is gray, layer 1 is red, default is black. Those just help me understand quickly which objects are on which layers. And it's good to use layers because I can do something like this, right? I have all these different objects. I can see the different colors. Okay, I can say, I need to turn off this one. Turn off layer 1. Hit the little light bulb, and now it disappears. FrameCAD, I don't want to look at the FrameCAD. Turn it off. I don't want to look at the plywood. Turn it off. Here's OCC Coast Collective. Turn it off. Or if I want to keep it on, I can say lock. Lock, 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 lock. Now I can't select anything because the layers that they're on are locked. That's nice because then I can just focus on this stuff here, and I won't accidentally move anything. Does that make sense? Okay, but whatever layer you're currently in, you can't lock that layer because you're in the layer. You can't turn it off because you're currently in that layer. But you can turn off the other ones, you can lock the other ones. Yeah.
Oh, I see.
Make sense?
Makes sense. Thank you.
Of course. All right, I'm going to end this stream.